This morning, I'm going to talk about building a lean AI startup, or I subtitled this, How to Start an ML Company in Your Garage, which is what we had the experience of doing a couple years ago. So yeah, I'm the co-founder and CTO of MadKudu. What is MadKudu? It is a lead scoring company that basically enables B2B companies to customize the journey of their customers at scale and everywhere. So this is the list of some of our customers, which we're pretty proud of, about 50 customers as of today. What is lead scoring and what do we do differently is, tend to call it, machine learning for sales and marketing, but really what we're trying to do is to have those companies have, information about their customers and knowing if they're good potential customers or good customers at every stage of the sales and marketing funnel. So in practice, what that means is we try to integrate with everything. So from marketing automation with folks like MadKudu, HubSpot, Outreach, obviously the CRM, lots of Salesforce, but also Freshsales, Pipedrive, and a couple others. We integrate with your live chat as well. So for example, if we identify that a visitor to the website can be a good lead, then you can decide on the spot to pop up a demo request. And also now we're going into looking at optimizing advertisement using that information as well. So we integrate with the entire value flow on sales and marketing. An interesting thing I think about a lot of those customers is a lot of those customers have data science and an ML team, and they still ended up, I think, working with us mostly because of that integrated aspect across the value cycle. So before we got those customers, my co-founders and I started as, small experience as data scientist and product manager. We started with no funding at all for about a year and working from this actual garage. It got really warm in summer. I would not recommend that if you can avoid it. And these days the garage are not even actually cheap in Silicon Valley, so not a great thing. But what I'm going to talk about today is basically about I think the talk is really for people here if you're looking at starting a company or have an ML ID or something that you're like, oh cool, I would like to bring that into the world or launch a new product, and you don't necessarily have a ton of entrepreneurial experience and a lot of cash on hand. How can you do that without spending your entire first year just building the ML part? So we'll dive a bit into how you can try being lean with AI and ML, some practical lessons we learned and things we did to iterate quickly. And I think I said focus on the product engineering with the side of go-to-market, but as I did the slide, I think it's going to be a bit more of like go-to-market and high-level practices, so not necessarily a lot of engineering, but happy to chat about that aspect in office hours afterwards. All right, so if you remember this is starting to be actually quite old. I looked it up and the lean startup started coming up in 2008, 2009, so it's actually about a decade old these days, but you're probably familiar with the build, measure, learn. There's been a lot of stuff mentioned about that stuff, but you're basically trying to do the thing, which is how can I go fast into dominating a market? It's kind of like the general idea. What's different? Quick note that I think I will use data science, machine learning, and AI a bit interchangeably in that talk. I've been confused by the marketing. I know they're not the same, but I think it's not. I think when we started, we used to call it data science, and now we call it AI for marketing purposes. Gonna use it interchangeably. Don't hate me for it. But so yeah, build, measure, learn. And the question I think we had is, hey, okay, what's different with? Is there anything different with building an AI or building a machine learning product? I think the main learning is it's generally harder, right? I think if you just try to build, measure, learn, you'll figure out hey, okay, what do I build? I found this stuff from an article from, I think Zeta Venture did a lot of pretty cool work on that subject. She's a venture fund focused mostly on AI products. But what you want to prove, I think, with your early product is three things. The first one is you want to make sure that the problem you're solving is actually solvable with AI or machine learning, which means usually two things: that you can collect and get the right data, and then that you can predict, slightly better than what a human could do, or that an existing system could do, or that a simple heuristic could do. The second thing you can do, which is different from the first one, which is, well, is someone actually going to buy this, or is this going to be useful? Because there's a category of product where you can completely do the first one, but then no one cares. And I'll come back to that a little bit later. And the third one is, okay, that's solvable, someone's interested, but can you actually solve this over time in the right circumstances? So this is a framework that the folks at Zeta put together, which I wish I had seen 3-4 years ago when we were getting started, which is actually a little odd to see, so I'll read it, but it's sort of a pyramid of building an AI/ML product. So at the bottom you have capturing the training data. Level above is training the model to what they call minimum algorithmic performance. Above that, you're going to test the model in real life. Then you want to capture feedback data, measure the ROI, and package it appropriately. So what they show with the left from the right is basically what you want to avoid doing, is just doing one horizontal layer and spend your time there. What you need to actually have a successful product in AI or ML is go through the entire pyramid, basically. And what's a bit missing from that graph is you probably want to do circles around that cycle to make sure that you get the entire value. Interestingly, on their graph, they highlighted the test model in real life. If you're like me and you're a data scientist or something, you might spend a little too much time, I think, on the one below, the trained model to algorithmic performance. For example, if you're a data scientist, if you're a data engineer, you might spend a lot more time on capturing data and serving it. So each one might have a bias. I think the point of this and the main lesson we learned building this is, how do you make sure you go through those steps as soon as possible so you can make sure that, in the end, someone wants to buy your AI product? So what I'm going to do next is I'm going to go a little bit through each of those steps and sort of errors or issues we made while going through them, and some of the basically lessons we learned in building this. So first step, pretty simple on paper, but as most of you probably know, is the big catch-22 of building data products, is how do I get data? Because you, as we mentioned, you need data to prove that your problem is solvable, and you need data to get feedback. I think that's a very important one. I think, main difference with regular lean startup, I would say, you'd have a lot of advice on, hey, just build a mock-up, go show it to your customers, and get feedback. I think if you tried that, and if you've already built like a dashboard or some sort of product to predict something, my finding is that it does not work for a data product. If you want to get feedback for a data product, you need the customer's actual data or some approximation of it. I think I've seen this go two-way. If you go the markup approach, it might be someone's like, oh yeah, that's cool, I want that, and then you build a real version, and I don't know if it's a dashboard, maybe it just doesn't move over time, or you always do those markup of dashboards that show cool stuff and impressive results, because obviously that's what you're going to put on the markup, and then you try it with real data, and it's a flat line, and you're like, great, okay. The opposite might actually happen, which is something that the customer might say, maybe, and then you show it with the real insights, and they're like, oh, wow, I want that, right? So I think that's an important difference with the actual, with the old school lean startup is, to mock it up, I think you need to have some level of data, right? So obviously, that's the big catch-22 is you don't have a product. How do you get a customer to give you data so you can get started? I think if you're a big company, sometimes you get out of that, and you're launching a new product, you get out of that conundrum because you're already capturing that data for other applications, and you manage to get access to someone in recommendation was capturing that data, and you can build another application on top of that. If you're a startup, well, you can't really do that because you have nothing existing. So what worked for us on that aspect is, I think we spent, I call it like it's a lot of like smoke and mirrors, but basically make it as easy for your customers to send you the data. That sounds pretty obvious, but it's almost like 90% of the engineering we did is like, okay, it's super easy for the customer to send us the data, and then it's really hard and really manual for us to do the things afterwards. But don't do the reverse, right? You want to make it simple for the customers to like, oh yeah, sure, I'd like to try this. Okay, one click, how can you get that data so that they don't have to, they're not gonna be able to say, oh sure, I'll assign a team for like 4 weeks to make you an extract from the data warehouse and blah, 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 right? So you wanna make that super easy. How we did that is, one was partnering with existing data repositories. So I think for us in sales and marketing, it was relatively obvious because most of the data already lives in Salesforce and Marketo and HubSpot, so we add access to those other sources of data. I'm sure for other products, there might be other things. One thing we did that, is a little tricky but dangerous is at the beginning, you're not sure what you're gonna need. So if you can get a little more than you need, it's usually a good recommendation, right? So don't, be a little greedy on what you ask at the beginning if you get access, because that will let you iterate at the margin relatively easily. Another one that's really more on the go-to-market side, but it's finding the right size of customer. I think if, your first customers ask you for an entire legal review and a month to get you the data, that might not be the right size to get started. You sort of want, if in our case, I think I was partnering with companies that were, had 1 or 2 data engineers that were able to maybe set a few things up or connect applications. But if you get into a team that is too large, that might take a little too long. Yeah, so a couple of fun stories from the smoke and mirrors. The smoke and mirrors is example is I think we were lucky enough to integrate with Segment, which is a great application for great source of data analytics if you can build an integration with them. I think these days they're a little more strict about what they allow as integration. I think we came at the point when we submitted the application, it was a Node.js API endpoint that would actually do nothing with the data, but return a 200. We got that on the marketplace, and then we built the pipeline afterwards. But that means that as soon as possible, our customers could start sending us data, and we could figure out what to do with it afterwards. So it was pretty cool of them. Really like them for letting us do that. The other interesting anecdote about that one is that endpoint in Node.js that sends data to SQS, I think hasn't changed in 3 or 4 years. It was pretty actually easy to build, dump the data, get it in a data lake, and then you can figure it later what to do with it. For the Salesforce integration, it was a bit of the same. It was a UI page where you could enter, you could do the OAuth flow to connect with Salesforce. We would save the access token to the database. And then we're like, okay, cool, now we can explore what's in Salesforce and see if we can find things to predict. So couple caveat for that one is, actually go to that one, is use some of your early engineering efforts. If you're going to ask for too much data, use some of your early engineering efforts to protect it correctly, because obviously the thing you want to avoid is getting that data and then losing it. That would usually be the death kiss for any startup. You want to ask for just it's like one of those, OAuth thing that Slack, if a Slack application asks you for access to all your messages, you might say like, okay, that's a little bit too much. So ask for a little bit more than what you need, but not too much. On the partners on the channel, I think it was kind of the same thing. It was finding the partners of the right size for us at that time. For example, we had a terrible experience with existing repository like MadKudu or Eloqua, we introduce another catch-22, which is you have to prove them that you have customers before they let you become a partner, and you don't have customers, so how do you get out of that catch-22 is a little bit tricky. But if you can find, for your AI product and you're looking at integrating with existing sources of data, I would recommend that you look at someone who's in the right size that will not have too much red tape that they won't let you take that data out. But that's a good trick that worked for us to get data to build that ML product. Second step is actually getting predictive. This one, I think, if you're a data scientist or engineer and you're thinking you're gonna start a startup, you're like, well, I know I'm probably going to spend too much time on this. I'm going to avoid that problem. I'm not going to be one of these guys. I think you're still going to be one of these guys. It's extremely tricky to not spend too much time on that step in my experience, right? I mean, you've had experience doing data science. You're going to be like, oh, cool. How can I improve that model? Really, I should be able to get better results. What if I use TensorFlow, Keras, or whatever? So you know it, but still, maybe tape something on your wall that says, don't optimize too much your model too early. A couple dead ends, I think. Oh, I didn't finish that slide. I think one dead end, why I mentioned that is I think one dead end we encountered was trying to predict churn. It was our initial, business idea in sort of that space. I think there's someone tomorrow with a talk about predicting churn, which I'm really interested in seeing. The reason I'm saying that is I think churn is a really good, you can predict churn on a data set, and you can spend a lot of time getting better results. The reason I would recommend not to spend too much time on this is for us, we realize at the next step that you can predict churn on the data set, but then what can you do about it? And we couldn't find the next step of getting actual usage or good feedback data. I'm willing to be convinced otherwise, but I still know that if your model tells you that someone's going to churn, it might be too late to do anything about it. So churn, I think, is really good at this step. You can spend a lot of time optimizing at this step, but in our experience, it failed at the next one, which is no one actually wants to pay for that, or the feedback cycle. The feedback cycle tells you that people do not get ROI from such an application. So the point here was like, okay, churn didn't have model market fit, and we didn't go fast enough to sort of like the capture feedback data and measure ROI steps, because initially we're like, oh, maybe we can predict this better, and by predicting this better, we'll get better results. So the solution that's proposed by Zeta in their paper was basically find something. I think they tried to find the ML equivalent of the minimum viable product, which I think they call minimum algorithmic performance. I think that's an interesting concept. It's an interesting concept to use. I think basically what this says is just try to find the simplest model that does better than the status quo and stop there. It's kind of the idea on that one. In our case, that meant starting with very, very basic regression and trees and not try any other things before getting to the next step. I would also recommend not trying increasing too much the complexity of the AI models, but instead looking at, can I get more data or can I get more dimensions in my data set? And again, this is the moment that if you're an engineer, you shut up every cell of your brain that tells you to worry about scalability, modularity, or any of those things. You'll get back to this if this works. Step 3, which is another very interesting one, is now, okay, now you've got to the point where you've gathered data, you've trained the model, performs pretty well on paper. Okay, now what do you do with it, and how do you get feedback on that model? And same recommendation on that one. I think on this one, I wanted to find errors we made. I think on this one, we actually executed pretty efficiently because we didn't have a lot of experience with data engineering, so we just figured out the fastest thing that worked, which was SQL scripts running on cron that would just refresh the data daily and we didn't know anything else. And we're like, okay, so we didn't overcomplexify that one. I highly recommend testing a full refresh batch model before doing any kind of incremental logic or real time or streaming or whatever. Because again, what you want at this point is showing the model to your customer and figure out if they're ready to pay for the benefit it brings them. So I don't think there's a lot of vendors of big data stack technologies today as sponsors, but I might not make friends with them if they're around. Is at this stage, I don't think you need a lot of Spark, Kafka, or any complex technologies. If you know them and you know them well, and you go as fast with them as you would with any other technologies, absolutely you should use them. But if you don't, I'm not sure that's the right moment in that cycle to really learn about them. If anyone upstairs, you're like startup founder, 3 people, 4 people, 5 people, they're trying to sell you that stuff up there at the expo, well, let me know because I want to talk to them. They're probably not doing a good job at lead scoring, but that's it's a different point. So I would say basically the learning at that step is keep things simple. And what we did then at the next step is basically, okay, now you've applied it, you've refreshed your model daily with the data coming in, which is kind of like the operationalization, but you want to keep that simple. And then the next step is basically how do you get feedback from your customers. I, as an engineer, made that mistake early on, which is like, oh, cool, we had instrumented the model, we were pushing scores basically in Salesforce for our customers, and I'm like, okay, done. Now I just need to find other customers. Turns out that, they were not really looking at whatever we were pushing to them, or we didn't know if I was helping them or not. So same thing as an engineer, that's actually the moment that might be the most complicated, which is, the moment where you're like, okay, does this work? And the best way still as in the lean startup to figure out if something works for a customer is to ask them for money. Really interesting story on that front from us was, I think my co-founder was doing Salesforce, went to one of our early customers at the moment, tried to have that conversation. And I think we started the conversation of, yeah, that's useful, and then, oh, would you be ready to pay for it? How much? And I think my co-founder started at, I don't know, like $1,000 a month. Nope. 500? Nope. We ended up selling a first deal at $50 a month, and I was kind of like, okay, maybe that's not creating as much value as we thought it would. So if you're building that as part of a company that's not yet making any money and you're trying to prove traction, make sure you ask that question early. One thing we did early on was actually, this kind of goes back to the previous step, but before even instrumenting it, we went just with like, hey, let's present a PowerPoint deck with the results of the model and see what they think. I think this one depends. We got some good feedback on that one, but I would say it's a good step to see if you're heading in the right direction, but you still need to go serve the model where your customer is going to use it, right? So it doesn't matter if you have a model that predicts well on your machine. If, say, our customer is our main user is a salesperson or a marketing person, they spend their day in Salesforce. Well, that's where the model needs to live, pretty much. I think initially we're like, oh, maybe if we build another application and we ask salespeople to, come and see another application to see the scores. No, not working. The salesperson wants to be in Salesforce. You want to serve the model there. And the last very important step for us at that point was like, okay, just serving it was not enough. If you wanna really be useful to a sales team or a marketing team, you need to be integrated with the process. Or you need to be really embedded in, are they using the product? Are they? For us to be very concrete, it is, okay, I'm predicting that this person's going to be a good lead. Does it affect how the sales team handles them? Does the sales team handle, good lead faster than bad leads? Does it change anything? Do they know it exists? Do they use it? So there's that step, that is very, again, kind of very annoying for engineers or data scientists, which is, okay, the moment where you try to train a sales or marketing team is not something that's necessary in your prior job description, but is very critical to make sure that you're just not, iterating in a vacuum. What's that on that one? Yeah, that one was an interesting one for me as well, because you're a data scientist, your model says, you're relatively confident that your model says that this is a good lead, and the customer's like, no, I don't think it's good, or has questions about it. Well, it sucks, but you're not going to win the fight by saying, hey, the algorithm says it is initially. I think you really have to listen to that feedback. And what we did initially is, okay, let's just override those things manually on top of the actual model so that we can uncover the next objection. Right? If your customer tells you, hey, I don't think that's a good lead, or I don't think this prediction's good, might as well just say, hey, let's go over that one and see, okay, now if I make it better, does it work? One way is just to override the model. And I think another learning is that I think that's always going to happen in a lot of scenarios. I think for sales team and marketing team, it's pretty obvious, but we have teams that do not sell in Asia. For example, customers who do not sell in Asia, if you tell them that a customer in Singapore is a really good customer and they don't have a sales team there, then maybe that's not as good a customer. So make sure you take those heuristic and business model rules into account so you can get feedback that matters. So this one's interesting. The last step in the pipeline is measure ROI. It is extremely important. I have absolutely no recommendation on how to do this. I think we're figuring this out, but I have not generalized that step. It can be difficult. I know that, for example, with churn, for example, is a really good example. Churn is a big problem for a company, but it's a small data problems, right? You have, you're lucky you're unlucky if you have, 50 customers leaving every month. That's very bad from a churn perspective, but from a number of data points perspective, it's really small. You're not going to A/B test that one with a significant level of, with any level of significance, right? So sometimes a good thing to remember. So that's why I don't have generalization on that one. I think on ROI, we tend to, actually not necessarily focus on accuracy of models and stuff like that, but almost on time saved. Sometimes there's actually a better metric. It's like, hey, it used to take me a lot of time, it takes me less time. It's not necessarily about returning better results or more accurate precisions. And the interesting thing, which I was mentioning then, that's missing from that entire framework, which otherwise really cool, is you'll probably need to go through that cycle multiple times, unless you're very lucky and the first idea you have for your AI product works right from the start. You'll probably need to go over that and try again. A couple tips that we implemented to do this is, I think the trap here is to create structure and abstractions too early. It's a trap because now that's what I've spent the last 2 years afterwards doing, is figure out the right structure and abstractions so that my company gets economies of scale from implementing those models. But you don't want to do that early on. The rule, it was actually a very explicit rule we implemented initially, called it the rule of three, not the most marketing friendly name, but let's wait until we've done a thing for 3 clients before even looking at building the abstraction, and then be very consistent about, okay, now we've done 3, let's build the abstraction that's going to let us go to 4, 5, 6. But we always said, okay, we've done that for only one customer. Let's not abstract the model. Let's not abstract the component or the feature generation pipeline or things like that. So yes, lots of spaghetti SQL. That's basically what happens. Same thing as an engineer. I was like, I don't want to see this. But as a startup founder, I was like, this is actually necessary. So be careful of balancing your instincts on that one. And I have one last slide, which is on team organization. I think if you're thinking of getting started with launching an ML product, I would say this sounds really obvious, but I don't think that can succeed if you don't have at least one founder that is an AI, ML, data science, data engineering practitioner. I don't think you can go through that cycle fast enough by outsourcing it or having someone junior that doesn't know the product, because really you want to go fast and mix the business feedback into your development loop. And for us, I think I worked pretty well. We had 2 founders with background in ML and one with experience in data pipeline and data engineering. So it was actually the sort of like a right mix to go through that cycle. I think if you have to make a trade-off, I would have the founder do the data science piece and hire on data engineering, but I don't actually have experience with that one since I didn't do it. And that's actually it. So if you're thinking of starting a company in AI or ML, I wish you good luck. And if for any case you meet anyone here today whose company is making them work on lead scoring or for their own thing, I think you should have them come talk to me. Thank you very much.
You talked about listening to customers a lot, and that sounds great. But when you add more customers, you're going to be having models that you're trying to make work for more use cases. And at some point, it's conceivable that you'll actually lose performance, maybe on some of the earlier things that you were doing. Mm-hmm. Do you have any thoughts on how to maybe think and plan for that?
Yeah, it's a really good question. It's definitely something that comes up at the later stage. Ideally, I think on this one, you build in, taking the example for us, which is, oh, cool, we have access to Salesforce, and in Salesforce, we can see the opportunity that I created. So you can see if, the models that were predicted good create more opportunity, and you build that into the model to get that feedback loop and get it automated. The performance degradation is tricky. I think what we built was a basic dashboard that reports it, and at some point when it gets bad, we retrain it. that was the initial implementation. I think that's definitely a concern. It's definitely a concern at a later stage. I'm not sure I have generalizable advice, but I think it's a very good thing to keep an eye on. I think the two things that would come after this talk is, okay, now, which is the stage we went in after those initial customers, which is, okay, now you need unit economics. Basically, if you have a data scientist train a new model for every customer and it takes them 2 weeks to come up with something good, it's going to work for the first 3 customers, but not after that. So that's definitely when you want to find those abstractions so that you can get good unit economics on training new models for new customers. And then it's maintaining them over time. It's like, is the performance still good? Am I monitoring it? Am I automatically retraining or manually retraining? And the third one, which we had to solve after this, which then you get into the Kafka and things like that, is deliverability and performance of just delivering the model in real time, for example. So definitely what would come after this step.
So you mentioned data partners, and with that, was it just that you integrated with, say, Salesforce Marketo? It wasn't like you signed a deal with Salesforce to share the customer data that didn't authenticate with you?
No. It was, in that case, it was really existing data sources that had good APIs, mm-hmm. or a good way to share the data.
Okay, so it was an integration. It wasn't. I guess I was confused with. Did you develop a business partnership with them to share data?
No, not yet. And especially with Salesforce, I think they don't want to talk to you until you have something to give back to them. Definitely, that's something that happens afterwards, right? Or today we actually integrate in a lot of marketplaces. So we're launching one for HubSpot next week. We're on Intercom, Salesforce. I think their marketplace is, I think we were asking too much rev share up front, and we're we don't even know how much revenue this is going to be. We're not paying you $10,000 up front to be on your marketplace. But no, that was really the idea of there might be existing source of data that your customers already has data in that you can build on top of. is good to get started. I think after a while you get in the decision that you may be seen as an add-on to those things, and then you might want to be, hey, I want to capture that data myself directly. But to get started and sort of get through that loop fast, if you can find existing data, that is a really good thing to do.
My question is mainly on kind of questions and asks you've probably got from customers. So it sounds like at MadKudu, you guys focused a lot on third-party SaaS, ETL, and then building your models and delivering customer value through that. When any of those customers that you showed say, we have really meaningful data from trials that deposit data into our product database, our users database, maybe other metadata databases that they have that they want to use for account-based marketing or whatever stuff, just whatever internal first-party data. How do you guys approach integrating that? ETLing that in? Do you guys do things like that? And what's generally the approach with, a non-standard data model that you can expect from an API?
That is a very good question. That's definitely something that happens, especially as you get to bigger companies or older companies. Where we approached it was say no early on. I was tricky. I was like, no, we can't do that. Then we did, cool, here's an S3 endpoint. Can you please dump us a file every day in this format? I think we tried that. Initially, usually that stops working after a while. The company's like, well, no, we can't do that. Just map it ourselves. So what we did is just like kind of same principle, like make it super easy for them to dump the data and you hide the complexity from them. So get the CSV file, but you'll have problems with that as well.
Just as like a follow-up to that, then basically that means that like your data scientists or data engineers would then transform that and integrate that into your overall data models?
Yeah, so we did kind of the same approach, was like, hey, the first 3 customers, just get the raw CSV dump and do whatever you can with it. And for the 4th, 5th one, maybe now you're like, okay, here's the data model I want the data in, or here's an API endpoint that maybe is going to do some validation ahead. So you can scale that. But I would say initially, my recommendation would be just take whatever they send you, as long as you can load it. As long as the CSV is not corrupted, you'll figure it out later.